And we're back doing the independent practice with Mr. Flan's art/geometry class for now. Okay, so we're doing art and geometry. Ooh, okay. So, all right, so let's look at this first question here. It says a 9 meter, excuse me, not millimeter, 9 meter ladder rests against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. Determine the measure of the angle between the ladder and the ground to the nearest degree. Okay, so you don't want to say nearest degree, that means nearest whole number. So we round up or round down to the nearest whole number. We don't have any decimals in our final answer. Okay, so again, I'm sorry for those who don't like to draw. I am with you. I'm not the greatest drawer, but I have to think about the situation. Here's the ground. Now, next I will put my wall. I'll make it a brick wall. All right, bricks go like that, right, and go down like that. So I got a brick wall. Make it a little taller. That's an ugly. See, look, see, I told you I can't draw very good. So there's my brick wall. And now I'm going to have what you would call it, a ladder. I'm going to use a brown one. Never used this brown marker. Have a brown ladder. Ladder looks something like this. Leaning against the wall. Right? Okay, see, look, here already here you see my problem comes in. I'm kind of a bad drawer, but that's okay. All right, so I got this problem. It says a 9 ladder. 9 meter ladder. So this ladder is 9 meters. So since it's brown, I'll put, right? 9 meters. This, from here to here, that means how long this ladder is 9 meters. Okay, that's not bad. It rests against the side of a wall. The bottom of the ladder is 1.5 meters from the base of the wall. Base, when we're talking about base in triangles, is always the bottom, right? When we kind of think of it as the bottom. The bottom of the ladder is 1.5 meters from the base of the wall. This distance here, again, I'm going to go with green because it's on the ground, I think grass, is going to be 1.5 meters. Determine the measure of the angle between the ladder and the ground. Not the ladder and the wall, the ladder and the ground. So this number here, make it orange. We got to find that. This is our x. Okay? All right, so now I got to find out what information I have, what information I don't have at this point. Well, first I got to draw in my right triangle. My little right angle there, excuse me. I go across to the right angle, and I find across from the right angle is what we call the hypotenuse. That's always the hypotenuse. It's always the longest side. So I know if I do something here and my answer is here, it's bigger than 9. Not good, right? So here is my other one. Okay, let's look at across from the angle. We want to find the opposite. So I look at my angle, I go across from it, and this here is my opposite. The wall is kind of my opposite. So that leaves only one thing possibly for the bottom part. This has to be the adjacent. So, the two pieces of information I have a hypotenuse and I have an adjacent. Now, which one of the SOHCAHTOAs has adjacent and hypotenuse? I get out my little handy dandy cheat sheet like we have, and I say, well, opposite hypotenuse, nope. Opposite adjacent, nope. Adjacent hypotenuse, there's adjacent, so I use cosine. So my function is going to be cosine, and it's right here on your cheat sheet. Cosine of theta equals adjacent over hypotenuse. Cos of theta is equal to adjacent over hypotenuse. Now, I got to solve for theta. So this is one of the ones where we're going to have to use the inverse. So if you do the inverse of this, remember, it's cos of -1 on the calculator. Inside here, you'll have your adjacent and your hypotenuse. close the brackets, and when you hit enter, you will get theta. And you see at this point, it's all calculator work. Okay, so let's write this out again with our numbers in it this time. Cos -1, so we're doing inverse because we have to find the angle. We have to flip it around. When you're doing the angle, when finding angle, use this. Use the -1. Okay? Now, inside my brackets, I'm going to put adjacent. Well, according to this, it's my green number. The adjacent is 1.5. Over my hypotenuse, which is my brown number. My brown number is 9. You see how it's a little bit easier to do this part if we have all the information set up here. Imagining this in my head would be very, very hard as far as what the opposite would be, what the adjacent would be. At the very least, I would have to sketch out a triangle. I don't know if I could do anything, but I'm just picturing this in my mind so it makes everything clear. Equals my theta, which is the theta we put in orange. This is the extent of the work we're doing. The calculator's doing this last little part. Okay, so turn on my calculator. Remember, if you're using Desmos, use the scientific calculator. That's the easier one to use for this. Scientific calculator in Desmos. I told you I just put up a Desmos tutorial. Hopefully that'll be good. There's our last question. Let's not do it. So this is what I do. Second, cosine. 1.5 divided by 9. Close. That's it. The computer's taking care of the rest. And 80.4. Well, theta, we're saying now, equals 80.4. But they said measure to the nearest degree. Well, it's 0.4 is less than 5. 4 is less than 5, so I round down. So the nearest degree is 80 degrees, and we put that little symbol for degrees. So that symbol up here is 80 degrees. You figured that out. Now, if you really remember from our triangles here, that means this one over here must be 20 degrees. No, 10 degrees. This angle must be 10 degrees. But don't worry about that right now. Worry about this. Think about these problems. You were going to have a project to work on this. It's very similar to what I want you to do. And I'll describe it more. Don't freak out about the artwork. I'll explain that in our next video that I'll probably do tomorrow or sometime after that, whenever I do the project. And I'll show you how to do it. I won't just give you a day to do it. I'll give you more than a day. I'll have maybe a couple of days. Okay, so katoa. You guys are doing great. I'll talk to you soon.